Okay, welcome back. We are going to solve problems about chapter 4, Newton's law. And there are 5 problems. We start with the first one. The first one say like this. You have an object that is made of 3 objects. This one, 5 kilogram. The bar of the rope, you can imagine a solid bar here of 0.6 kilogram and the mass V. So both are connected by this rope or by this bar, 0.6 kilogram rod. The link between the broken rod and the node by A and B. What is it? The links between the blocks are this is the links A and B. Okay. And the force is applied to the upper block. So there is a force in the upper block. So the question is say in figure 4.2, move downwards at constant velocity. Then the force applied, this force applied is, so we have to find the force F that you need to apply in order to the whole system of 3 pieces, 3 objects, to move downwards with constant velocity. Now, to move downwards with constant velocity means that the acceleration is 0. And what Newton's law say is the sum of all the forces equal the mass by the acceleration. So if there is 0 acceleration, it means that the sum of all the forces should be 0. So what are the forces acting on on the system, on these 3 pieces? For one side, there is 5 kilograms, so there is 50 newtons going downwards. There is 0.6 kilograms, 6 newtons going downwards. 0.6 by 10 is 6 newtons. 4 kilograms, there are 40 newtons going downwards. 4 by 10. Okay, so the total force that is acting on the body is 50 plus 6 plus 40. So there is a total force acting on the body that is 96 newtons going downwards. The velocity is constant and the acceleration is 0. So if I have 96 newtons going downwards, I need to apply a force of 96 newtons going upward in a way that the sum of the forces will be 0. So the correct answer is 96 newtons going upwards. What happened if the object is moving up with constant velocity? If the object is moving up with constant velocity, the result will not change. The 96 newtons will be needed to perform a motion with 0 acceleration, with force 0. Okay, let's go next problem. The next problem, it say like this. Let's go, I'm sorry. It say there is a lady here. The lady is not very, it doesn't have a lot of strength, so he tried to pull the cradle up with a force P. So this is the force that the lady is doing on the cradle, P. The cradle have a force going downwards, that is the weight, mg, going downwards. And C is the force that the floor is going up. Normally we call in this force N, the normal force. But in this problem they call the C. So what happened? It say like this, it's too heavy with another for P, C, how are the magnitude of these forces related with the person is trying unsuccessfully to lift the cradle? If he tries unsuccessfully to lift the cradle, it's because he performed 0 acceleration. So we need to make the sum of all the forces, and we need to be equal to the mass by the acceleration, but in this case, the acceleration is 0. What are the forces that are acting? The P, the force that the lady is doing, the C, the force that the floor is doing, and the omega, the force that the weight is doing. The sum in vector form of these three forces have to be 0. Now what happened now? Now, in magnitude, it means that I have omega going downwards, the weights. So this amount of weights have to be, the sum have to be 0. So whatever I have downwards, let's say that I have 10 downwards, 10 newtons going downwards, so I need to have 10 newtons going upward. So if the lady can push up with 1 newtons, the normal force will be 9 newtons, in a way that 9 plus 1 will be the 10 going downwards. If the lady is pushing the back with 8 newtons, now the normal will be 2 newtons. It will decrease. So you see, these are the picture. The weight is fixed. The P, let's say that now is increased. So the normal have to be decreased. But the sum have to make acceleration 0 always. So what is the question? Let me see, read the question. What is the correct answer? The correct answer is that I need to have up as much force as I need to go as I need downwards. So the force going up is the force P plus N or plus C, and this have to be equal omega, or in other words, P plus C minus omega should be 0. So what is P plus C? P plus C is P plus C. Oh, is this one. What it say that P plus C, what is omega? Omega is this one. What is minus omega? Minus omega is this one. What it says is that this amount and this amount have to be the same one. Wow. So the correct relation is that P plus C should be equal omega. Or, if you prefer, whatever is positive, P plus C, adding with whatever is negative, minus omega, should be 0. So P plus C should be equal omega. So choose what is the correct answer in between the several options. So let's go to solve this question now. Next question, it say two blocks A and B are being pulled with in an horizontal surface. So it's a horizontal surface means that the weight is not acting in the horizontal direction. So it's 100 newtons pulling the object MA and 100 newtons pulling the object MV. This object is light. This object is more massive, have more mass. Both of them are moving with constant velocity. So it's say for the object V, what is the even if they have different masses, what is the diagram, the free diagram that is possible? If you have the object V that is being pulled with 100 newtons, and I want the velocity V to be constant, not to change, so it means that the acceleration is 0. So if I want 0 acceleration, I need 100 newtons going to the left. So what is the result? What is this? This one is not. No, this one could be this one, could be this one, and also could be this one. This one, no. No, because I need 0 acceleration, so I need 100 newtons going to the left. So these two are possibles. I don't know which of the figures below show a correct free body. The other, I think it's correct what I said. Next question. The next question it say is a problem. It say you have three forces, F1, F2, and F3. Every one have different directions, different magnitude. This one is 600, this one is 200, this one is 1150. It's a make the sum. Well, F1, F2, and F3. How do I make the sum of three vectors? I start with F3. I put it F2 here. You see F2? This is F2. I put it F1 here, and the sum is this plus this plus this, or the sum is the blue one. The blue one. So what the problem is asking you is a problem about vectors. Make the sum. So you make the sum. So to make the sum, you know how to do it. I'm not going to explain too much in this problem, but F1 can be written like 600 cosine of 30 I plus 600 sine of 30j. F2, you know how it can be written, is 200 cosine of 180 plus 200 sine of 180. Always the angle is measured through the positive x-axis. Of course, that sine of 180 is 0, so this one will not appear, Okay, and F3 is 1150, F3, let me erase here, okay, 1150, F3, cosine of 233, cosine of 233 means this angle, if I didn't make this mistake. I plus 1150 sine of 233. Okay. It's correct, it's 180 plus 53. 180 plus 53 is 233. Okay. So, but I don't like to write the vector in this way. I like to write it directly. This is the same vector, F1, F2, and F3. You know, because you have studied already chapter 2 about vectors, F1 will not change, but F2 can be written like minus 200i, because cosine of 180 is minus 1, and if you see the picture, if you see the figure, it will be minus 200i and 0j. And F3 can be written in this way, minus 1150 sine of 53, where 53 is this angle. Let me show you the 53. This is the angle 53. 53 is this angle. This angle is 53, okay? 53. So it has negative component in the x direction, negative component in the y direction. So I put it negative and negative, negative and negative, and I work like this. And the sum, you make the sum, the total force. And you make the total force, and you sum it components by component, the I with the I, the J with the J, and again you will arrive to a vectors that when you make the sum, well, you know how to make the sum, you know what is the magnitude of this vector is this square plus this square. This is the magnitude of the vector. I guess that the vector, this total force will be in this direction, so it will have something negative in the x direction and something negative in the j direction. So you make here the calculation and you find the correct answer. Now let's go to solve the last problem. The last problem about Newton's law, it's you have two masses, 300 and 240 grams. And the rope that is here have a critical tension that when you pull it with more than this tension, you break the rope is being broken. So I think that the tension for the upper rope is more than 7.8. It breaks the rope. So have to be T2 have to be the force pulling up have to be less than 7.8, but it has another condition. The rope that is here between the two bodies is a different rope, different quality of rope, so it will not allow tensions bigger than 3.6. So the tension T1 should be smaller than 3.6. So under this condition, what is the maximum tension that the system can take? What is the larger upward acceleration that the block can give? Okay, and if the upward acceleration is slightly higher than this, which string breaks? Okay, which string breaks? Okay, so you isolate the body. The body is composed by the two masses and the rope that have no mass. Okay, so there is force going downwards, M1G and M2G is going downwards, so there is 3 newtons going downwards. 300 grams is 0.3 kilograms. 0.3 by 10 is 3 newtons going downwards, 2.4 newtons going downwards. So we apply first the Newton's law to the system of the two particles, M1 and M2, and we imagine that there is a tension T cannot be higher than 7.8, so the equation will say force going up, T, force going downwards, M1G and M2G. These have to be equal, M1 plus M2 by A. So I produce acceleration in this direction, in the direction of the total force, and this T have to be the maximum, it will be 7.8. So I have 7.8 going up, the maximum. I have 3 newtons going downwards, the weight. I have 2.4 going downwards, the weight of the M2. And this is mass by acceleration, but the mass is M1 plus M2. M1 plus M2 is 0.3 plus 0.24 is 0.54 A. Okay, if I make the sum here, it will be 2.4, 7.8, 5.4 is 2.4. 2.4 divided by 0.54, it will be an acceleration of 4.4 meters per second squared. Now we have to check if with this acceleration, the rope that is here will not break under this acceleration. So in other words, we have to find the tension that is pulling the mass M2. So the tension that is pulling the mass M2, now M2 is moving with acceleration 4.4 meters per second squared. And it's been pulling by the rope with a tension T going up. So what Newton's law says, the sum of all the forces. The sum of all the forces equal mass by acceleration. What are the sum of all the forces? The tension is going up, positive, equal to A. The weight is going down, negative, M2G. So it's mass by acceleration, positive acceleration, because it's going upward. I have chosen the positive direction going upward. So T minus M2G will be M2A2. So I need to calculate T. So the tension will be 3.06. So T minus 2.4 equal 0.24 by 4.4. This is 1.06. This is 1.06. So the tension, so I'm safe. The tension that pulling the mass M2 will be smaller than 3.8, 3.6, you see? That is smaller than 3.6, so it will not break. So if I apply a bigger tension, bigger than 7.8, the rope that is here will break, and this one will not break. So I have answered the both questions. Good luck.